Hello everyone, this is the Problem of the Week solution video for November 27th Problem of the Week POT. We will first read through the problem description and then go over a example solution in Python. So the problem description goes as follows. A teacher has sent an email to her students with the following task. Write a program that will determine and output the value of x if given the statement x equals the first number raised to the power of the first power, summed all the way up to the nth number raised to the nth power. And it holds that all the numbers are integers and all the powers are one-digit integers. But unfortunately, when the teacher downloaded the task to her computer, the text formatting was lost, so the task was turned into this. X is equal to all the numbers just added up together. For example, without text formatting, the original task in the form of x equals 21 squared plus 125 to the power of 3 became a task in the form of x equals 212 plus 1253. And our objective here is to help the teacher by writing a program that will, given n integers from p sub 1 to p sub n, determine and output the value of x from the original task. So basically we can do this by, instead of the exponents being clumped together with the bases, like once the text formatting was messed up, we want to split those apart. We can decipher this because it's given that the last number will actually be the exponent, and using that we can solve the original problem by pulling the base and exponent apart. And going over to our input section, it says that the first line of input contains the integer n, so that will be the amount of inputs that will be supplied to us, and it says it will be between 1 and 10. And it says that each of the n lines contains the integer p sub I, and that will be between 10 and 9,999. And the output says that we will only output one line, and that is the original sum, so that's the sum that was expected from the problem. And here's some sample inputs they give to us. We can see here the supplied value n says that it indicates that 2 inputs will be supplied. And our output will be this 1,953,566 number. And we have a few other inputs, but we will go over that after we touch on the example solution. So right here, first off, we need the value n that is given to us. So we assign this to the num inputs variable. In Python, the input method returns a string, so we want to cast that to an integer so that we can use it to anticipate our n amount of inputs. And then here we just assign a sum placeholder value, which we'll use to produce our output. Our next step is to go through this loop n times and prompt input for these numbers. So all these numbers that we haven't split the base and exponent off of yet, they'll just be stored in this temporary variable. And as said just before, it'll be a string. This is useful because Python string operations are pretty powerful. We can do it in a very short way. And then we can turn it into an integer to do our math on later on. So basically, our next step is to isolate the base and the exponent from our messed up text formatting string. Since we know that the base is going to be everything except the last digit in the input, we just do the string operation. So temp, and our colon indicates that we will be going from the beginning all the way up to the index -1, which is the last letter. And in the second line, we kind of do the opposite. Our power, in the problem it said that it would be the last digit. So right now, we would go starting from the last digit, going all the way from the end of the string, which actually just gives us the last digit. And then after this, we actually need to cast them all to integer, because if you recall, this is a string, so that we can do base to the power of power, and then we just add that to the total, and then our last step is pretty much just printing it out. So let's try some of our sample inputs. Our first one is, let's have 2 inputs, and our numbers will be 212 and 1,253, and our expected output is 1,953,566. Which it is what we get. So let's try our other ones. 5, 23, 17, 43, 52, and 22. It should yield 102, sorry. And that does yield what we expect. And last, 3, 213, 102, and 45, that should yield 10,385. And it does. So This program is behaving as we expect it to be. That is about it for this solution video. If you guys have any questions, I believe you can put questions into Remind or email. See you guys next week.